In 1905, Albert Einstein proved a precise relationship. The inertia of a physical body depends on its internal energy content. Standard physics treats the speed of light, c, as an axiomatic input, a measured invariant constant that sits at the base of our standard models. Special relativity defines c purely by its kinematic properties, the invariant speed of massless particles. It identifies what the constant does, but it lacks a derivation for why the constant exists at all. To convert the mass of an object into its energy equivalent, dimensional analysis requires a specific multiplier measured in meters squared per second squared. Dimensional analysis dictates the units required to balance the equation. It provides no mechanical account for why a specific velocity squared bridges a stable physical identity to the release of energy. Modern physics accepts c squared as a mathematical necessity for equivalence, yet the underlying geometric explanation for this specific factor remains missing from the standard model. The oscillatory dynamics transductive bridging theorem, or ODTBT, provides a rigorous recursive scalar framework to identify this mechanical origin. Within this framework, c manifests as the emergent maximum resolution rate of the underlying physical substrate. By tracing the mechanics of this field, we can show that c is a derived ratio of substrate properties, mass is a state of locked coherence, and c squared is the mandatory exchange rate between them. E equals mc squared represents the structural relationship between two states of a single underlying field as it projects into observable spacetime. Classical electrodynamics describes the vacuum using two measured constants, permittivity, or epsilon naught, and permeability, mu naught. These values correspond to specific ODTBT substrate properties, recursive permittivity, epsilon rec, and recursive permeability, mu rec. The speed of light is the emergent result of their product. Epsilon rec governs the substrate's capacitance, how much phase strain the field accumulates per unit of coherence input. Mu rec measures the substrate's inductance, or its resistance to torsion memory discharge. Their product establishes the absolute information delay of the substrate. This geometric mean sets the limit for how fast information can resolve across space. The basic observable event in this field is the scalar emission unit, or SEUK, a localized moment where the coherence field resolves into a visible state. Light manifests as a continuous sequential chain of these SEUK emission events. Because light carries a Locke potential of zero, it propagates with zero recursive overhead, traveling at the substrate's maximum resolution frequency. Nothing travels faster than light, because it is physically impossible to resolve coherence events faster than the substrate's fundamental resolution rate. While light propagates freely, massive matter requires a different configuration of the same underlying field. Transitioning from light to mass requires a topological mechanism capable of trapping the coherence field in a localized recursive loop. This trapping is driven by the Locke potential. We define the coherence density as the amount of recursive energy stored per unit volume to maintain this lock, balancing phase strain against curvature retention. Mass is the coherence density integrated over the effective projection volume. It is simply the locked state of the rest energy. Since mass and energy are two states of the same coherence field, we must explain why their exchange rate is explicitly a velocity squared. The answer lies in the ODTBT recursive energy density equation, which is defined by the product of two distinct field variables. The first component is phase strain. The second component is curvature retention. Each individual field component resolves through the substrate at the one-dimensional rate of c. Because total energy is the product of these strains resolving simultaneously, their rates multiply. This generates a two-dimensional geometric area element, c times c, setting the energy's resolution scale at c squared. This document formalizes to two distinct states of this coherence field. In the locked state, energy density is stored internally to sustain a stable identity, which we observe as mass. In the released state, the lock is broken, and stored coherence energy propagates outwardly. C squared is the necessary exchange rate to convert a one-dimensional locked identity into a two-component energy field propagating through the substrate. When mass converts to energy, such as in a nuclear reaction, a bifurcation event breaks the ZdV0 lock, releasing the stored coherence. This derivation is consistent with special relativity, which remains the correct kinematic theory for the projected layer of reality. The invariance of C holds true within any uniform coherent state of the local substrate. ODTBT introduces substrate relativity. C is invariant to the observer, but relative to the substrate's internal geometry. If physical configurations modify local epsilon rec or mu rec values, the substrate changes. Consequently, the effective propagation speed of coherence events shifts from the vacuum value. E equals mc squared reveals that mass and energy are two states of the same recursive coherence field. The factor of c squared is the geometric signature of the substrate's maximum resolution limit.